me and they get me for 600 me, he said, Mr. Rogers' bald head. It's just like, what?
That's funny. All right, okay, we're gonna let's do this thing. 7.2 sample proportions. Candy Machine Athlete will send you directions on how to do this. So this is based on the results of it if you bother to do it. If not, you'll just have to memorize it. All right, so basically what's happening is we know what the true population proportion is. And then we look at samples. And then we look at the shape of the sampling distribution. The shape of our sampling distribution is determined by the proportion, the true population proportion. If 90% of a candy is orange, and then we do samples, that's going to change what the samples look like. They're going to have a lot more orange in the samples. If they're 90% yellow, that's going to change it. Same thing with the center, changed by the true population proportion. And then we found out that the spread is changed by two things: how many samples there are, and then also the sample size. All right, is it okay to say that the distribution of p hat is approximately normal? So what's going to happen here is, again, not from here, but what we're going to do is we're going to want to be able to say that the distribution of samples is approximately normal. And we can do that as long as we have 10 failures and 10 successes. Remember, P is success, 1 minus P is a failure. So if we predict or we expect 10 failures and 10 successes and 10 failures at least, then the sample proportion or the sampling distribution of the samples will be normally distributed. And it's part of the state step. And here's what happens. We will be doing this every time so we can do our normal CDF type stuff. All right, what are the mean and the standard deviation of the sampling distribution proportion? Are these formulas on the formula sheet? What are conditions that need to be met? So these are on the formula sheet. These are actually pretty easy. Mu, the average of the averages is equal to the true population proportion. You do not need a condition for that. That is true every single time. The standard deviation is a little more it's success times failure divided by n and then the square root of that. And the condition is that, remember, for standard deviation, the condition that we match with that is that this must be independent. And to show independence, we need that the sample is less than 1/10 of the population. That's how you get your new mu and sigma to do normal CDF. Easy? Not so much. But you get the formula. Superintendent of a large school wants to know the proportion of middle school students in her district planning to attend a four-year college or university. Suppose that 80% of all middle school students in her district are planning to attend. What is the probability that an SRS the size of 125 will give a sample proportion of at most 75%? All right. So in our write-up, we got state, do, conclude. Look at that state step. A lot of stuff. A lot of stuff in the state step, and you're going to have to get used to that. The do and the conclude are pretty easy, pretty much what we've always done. The hard part is going to be getting the new mu and sigma to type into this equation. Okay, also, I need to define my variable, and then I'm going to solve sigma p hat, mu of p hat, and I get those two numbers, I show my work. Also remember, and then also we need to establish that p hat is approximately normal by doing the 10 successes and 10 failures. This one we expect 100 successes and 25 failures, so the sampling proportion, or the p hat will be, sampling portion will be approximately normal. And then right here, again, we assume, since this is a trick that we use, they tell us what the sample size is, so when we say we assume that the population is bigger than, you just stick a 0 at the back end of that one. 1,250 instead of 125. So then that means that this is less than 10% of this, of the population, as long as it's more than that number right there. So there's our new mu and sigma. We plugged those in. They said at most 75%. So we want less than or equal to 75%. Answer the question in a sentence. Lots of context. But again, this problem really isn't that bad. It's just normal CDF. And since the start of chapter 5, or I'm sorry, chapter 6, we've been doing normal CDF, and the hard part is getting new mu and sigma, not doing the normal CDF. All right. 7-2 video.